Hi everybody, this is the Unit 6 Systems of Equations test review. So number 1 says that they've graphed the lines y equals 5x plus 4. So I see that right here, a y-intercept of 4, and my slope is 5. So up 5 to the right 1, down 5 to the left 1. And I also have the horizontal line y equals 4, so notice my slope of 0, and it has a y-intercept of 4. Okay, so when I look at these equations, what I do actually notice is that they both have y-intercepts of 4. And that is exactly what we're looking for here because it says, what is the solution? That is, where do they intersect? I want to know where these lines cross. So it's at this ordered pair, and we always write it as an ordered pair, x and then y. And it's right there at the y-intercept of 0, 4. So number 2 is asking us to do something very similar, but now we have to graph them. And then it's asking for the y value where these are equal. So again, we're still looking for the intersection point, but this problem only asks us for the y value. So we have 2x minus 1. F of x is the same thing as y. It's no different. So my y-intercept is negative 1, so I'm going to start down here. And my slope is 2 over 1. So up 2 to the right 1, up 2 to the right 1. I can also go down 2 to the left 1. And I'm going to connect that with a nice line with arrows on both sides, showing that it goes on in both directions forever and ever and ever. Okay, my second equation is g of x is equal to half x plus 2. So again, that's the same thing as y equals, no different. And I'm going to start up here at positive 2 because that's my y-intercept. And my slope is 1/2. So that means up 1 to the right 2, up 1 to the right 2. And again, I can go down and to the left, so down 1 to the left 2. And again, I'm going to connect that with a nice line. And I'm looking again for the intersection point. And it's only asking me for the y value. So if I look at where these cross, it's right here. Let me switch colors. Okay, in red, this is where they share a point. And it looks like that y value is 1, 2, 3. Okay, in the next section, they are saying that we can use substitution or elimination. So I'm going to be using the one that's easier. So in number 3, I'm going straight for substitution because I see the y is by itself. So I'm going to substitute in x minus 4 everywhere I see a y. So negative x plus, now I'm going to substitute. So this x minus 4 is substituting in for y. Combining like terms, I have negative x plus x. Well, that's actually 0. So I'm left with negative 4 equals negative 4. It sure does. Because I get the same thing on both sides, these are actually the same exact line. These two lines would be directly on top of each other. So where would they cross? Everywhere. So this is an infinite solutions. Number 4, I'm also going to use substitution. 8x plus 13 is what y is equal to. So everywhere I see the y, I have to put 8x plus 13. Because I have a coefficient of negative 5, I'm going to add in the parentheses so I can distribute. So distributive property with my negative 5. So I have negative 4x minus 40x, and then negative 5 times 13 is negative 65 equals 23. I'm going to combine like terms, negative 4x and negative 40x. Those ones are like terms. They both have an x. So that becomes negative 44x minus 65 equals 23. I now need inverse operations so I can get my x alone. I'm going to add 65 to both sides. 23 plus 65 is 88. Because negative 44 and x are touching, that means multiply. So my last step is going to be by dividing by negative 44, and 88 divided by negative 44 is negative 2. That's my x value. To find my y value, I need to sub that back in. So I have right here, y is equal to 8x plus 13. So if I take my x and substitute with negative 2, I now have 8 times negative 2 plus 13. Negative 16 plus 13 is negative 3. And there's my solution. In number 5, I'm set up for elimination because I have all my terms on top of each other. My x's are lined up, my y's are lined up, my constants are lined up. But now I have to determine whether or not I want to cancel out the x first or eliminate the y first. It doesn't matter, whichever one seems easier. So what I think I'm going to do is I'm going to cancel out my x's. So I'm trying to match this. I'm trying to match 4x. What is going to cancel out with positive 4x? Negative 4x. So I need to make this 2x equal to negative 4x. What do I need to multiply by? Negative 2. If I distribute this negative 2 to all three terms, negative 2 times 2x is negative 4x. Negative 2 times 4y is negative 8y. And negative 2 times negative 4 is positive 8. So I'm going to add that together with my other equation. So 4x minus 4x, I knew that was going to eliminate. That's how I set this problem up. Now I have positive 8y plus negative 8y. Oh, what's happening here? Those are canceling out too. So this side's 0. Negative 6 plus 8 is 2. Last time I checked, 0 was not equal to 2. So this would be a no solution. I know that these lines would be parallel. Same slope, different y-intercepts. Whoopsies. Okay, number 6. I'm going to clear this so I have some more room. Again, I'm set up for elimination here because my x's and my y's and my constants, everything's lined up. So what I'm going to do is, again, determine what I want to cancel out. I already see that I have a positive 3y here, and I have a negative y down here. So I already have the positive negative thing going for me. So what I can do is just multiply this bottom equation by 3, and that'll give me my negative 3y that I need. So I'm just going to rewrite the top one over here. Now I'm going to distribute my 3. 3 times 5x, 3 times negative y, 3 times 3. I'm going to add these equations together. That's going to give me 17x. 3y plus negative 3y cancels out, and 8 plus 9 is also 17. So when I divide both sides by 17, I get 1. Substituting this back in, now I can pick either equation I want. I'm actually going to do both in this one just to show you that it really doesn't matter. I should get the same y value no matter which equation I plug it back into. So if I plug it into the top equation, we have 2 times 1 plus 3y equals 8. 2 times 1 is 2. I'm going to subtract 2 from both sides. That gives me 3y equals 6. So when I divide both sides by 3, I get 2. So there's my answer. There's my ordered pair. Now just to check, just to be sure, I'm going to plug into the other one as well. 5x minus y equals 3. 5x minus y equals 3. 5 times 1 is 5. Minus 5 on both sides. I get negative y is equal to negative 2. So then I know that y equals 2. Same answer. My y value is 2.